Hello team, this is a topic about atomic transaction for multi-device levels.
Yeah, hello for joining team today. So yeah, as Yuri said, the idea here is to be able to push, so when you're going to have a CBA, the action that you have in your CBA might configure multiple devices, right? That's very plausible, right? You know, for instance, in the example I shared, let me bring back the example I shared yesterday. For this example, for instance, okay, when you want to push like the ISIS peering config to your topology, here you will basically configure multiple devices.
Are you sharing your screen?
No, I'm just looking at my screen.
We're checking. It's a way of doing it, right?
I was looking at my screen. Sorry about that. Can you see my screen now? Okay. So for the ISIS peering config on a spine leaf Tor type of topology, like DC topology, imagine it's day 0, right? And you need to do that for the first time. Or imagine it's a core network, or whatever it is, right? The point is, you will have to configure multiple device as part of one action, okay? So here we said that we define the resources and the config template once for the ISIS config itself and for the loopback, because an ISIS requires a loopback to participate in. And finally, you can define a script to put the config in. Here, this script needs basically, for the config push, it needs to be atomic. So as part of my intent, configure ISIS on this PNF, I want either my action to succeed, and then I have ISIS configured all across the PNF that I define as input, or I want my action to fail, and then I have nothing configured across my topology, right? So it's either everything, either nothing.
Question, Alexi, is for these set of use cases, they need to be executed at the same time, or can they be just executed whenever the device is available?
So,
or the resource is available, so. The
idea here is that as part of the intent, you're going to say configure ISIS peering on these PNF, so they are available.
So we talked about the queuing mechanism, right?
There is no, yeah, but this is not applying here, because it's one transaction to be applied on 3 different devices.
Let's say they're parallel transactions, right? And
no, I don't want to complexify things.
Okay.
I want to keep things simple for now. I'm going to have, imagine, okay, configure ISIS peering on 3 PNFs, okay? And so now this boils down to that I'm going to have 3 transactions as part of this overall action, 1 to each PNF.
Yes. This is building upon what we talked about with queuing mechanism, or do you want to do separate implementation here? Because we also have, you know, different execution.
So the queuing mechanism is we're queuing requests to the same device. Here we're talking to 3 different devices. There is no queue.
Right. So for those cases, let's say there is, okay, so you have a use case where there is availability, right? And
yes.
There's nothing there, right?
Exactly.
So for those cases, we're still going to the execution management that we talked about.
Yes.
And we're looking for availability and priority.
Yes.
Do we want to execute all these actions when all the devices are available, or do you want to wait until you know, those availabilities are made before you push all the configuration?
Good question. This is an intent, right? And it's all or nothing. So if all the devices are not available, I'm waiting. I have to wait.
Okay, so you're waiting for everything, and then you want to push all the...
Yeah.
Okay.
Yes, that's the idea.
Okay. So, and this would be built on top of whatever we're building with...
Exactly. This is
it's just different...
CBA specific. So this is on top of the platform.
Within an action, within the CBA, it's just you're doing multiple... Okay. So one other thing is like, how do we know we need to execute all these actions together? Should we model that, or?
So that's what I was saying. I'm trying not to go too complex.
Okay.
Or I'm trying to keep things simple, because what we're starting discussing here is adding a lot of complexity to what I'm trying, but and it's irrelevant to the point where I'm going.
Okay.
But this is very important though. But the point here is that we're assuming everything is available. We're assuming with in the right word, and when I execute this action, it can go directly. Okay. And so it means that for the user, that top level action is seen as, the action is one transaction in the eyes of the user. And this transaction has to be atomic. So the user wants this action either to fail, either to succeed. Okay? But in reality, this action under the hood, because we said this action is to configure IS peering on 3PNF. Okay? So basically, I know that under the hood, I'm going to have one transaction per PNF, right? So in this case, I'm going to have 3 transactions.
Presumably 3 transactions have a rollback as well, right?
Sorry?
Every transaction, you probably have to have a rollback.
Exactly. Yes. This is exactly, the point.
Not transaction. Yeah.
And so each transaction, as Dan said, you need to consider failure or success for the transaction, okay? And if failure, then you need to roll back, but you also need to roll back all the previous ones that might have succeeded, okay? So that's the premise of what I'm going to present now. And what I can say is I have a solution to this. But the solution I have to this is only for the netconf protocol, and is only if the device supports the commit confirm capability. Okay, so that's what I'm going to present right now. This is the premise. If I don't have netconf nor commit confirm, what I'm going to present right now has no value. But if you have that, then good for you, and you can leverage this. Okay. Now so that's one. If the protocol is netconf and commit confirm supported, then let's say it's okay. But then here we need to find solution if not supported. That I don't have the solution right now, and we need to build a framework around this. Basically, with exactly what you said, each transaction should have basically like a commit and a rollback type of implementation. But
or commit payload and a delete payload.
Or commit payload and a delete payload. So here we need to consider commit and rollback as part of this transaction. If it's, actually this is regardless the protocol for this guy. It can be here. It can be netconf. It can be CLI. It can be RESTconf. It can be basically anything. For any other type of protocol, I want to implement like a commit and a rollback. So transaction equal commit plus rollback, basically. And please help me make this clear. I'm trying to get notes with you guys to build this, and so it's clear afterwards.
So, what type of rollback do we want to implement? Is it like, are we trying to implement the rollback, just rolling back the commit itself, or is it doing a configuration that would disconnect, for the successful use cases, disconnect what was configured?
So the rollback either is a rollback, like a rollback one, or something a vendor-specific rollback RPC.
That's what the current netconf protocol based on the commit confirm capability?
No. Commit confirm I will explain in a minute, in a few minutes. Okay. This is different. Here, the rollback either it's a delete template, so the commit you have basically a merge template, and the rollback you have a delete.
Because for rollback, we can execute an action of disconnect, or, disconnect that, delete. Yes, and generate a content.
Yeah, for the delete.
Yourself.
So that's one solution.
Yes.
Another solution is to, some vendors, they provide a rollback RPC.
Yes,
Like,
based on some ID, right?
Yeah, exactly.
It's going to give you a commit ID, and then you can say rollback that commit ID.
Look,
Rollback that specific commit ID?
look, let me showcase one example I have. I can show you guys here, if you give me just a minute.
Oh yeah, maybe not.
For instance, here for Junos rollback, Junos has this RPC, okay?
Rollback the last one.
This is a vendor RPC, and here I'm rollbacking the last one. Exactly.
As long as you didn't allow any other transaction while you're doing that.
And the premise is it's locked.
So the premise is all the devices are locked until everything is executed.
Yes.
Yeah.
And all are unlocked.
Yeah, you're right. Maybe I should have explained. So,
Good, because it's good stuff to have.
but yeah, so I will show you the implementation for the netconf commit confirm, and maybe, okay, let me show that, and then we can talk about the others, okay? For the commit confirm, so what should I show? I can show you guys a script. Let me be nice and let me show a script I've written for this, for one of our use case. Okay, so first people need to understand the commit confirm, how that works, okay? So let me explain that. In netconf, so you arrive in netconf, if you do a commit, then it's going to commit the candidate data store to the running data store, okay? If you do a commit confirm, it's going to commit if you do a commit confirm, you need to specify a timeout, okay? And basically, it's going to commit the candidate data store to the running data store, but if there is not a subsequent commit, then it will roll back automatically after that given timeout is expired. Okay? Maybe.
So you will roll back the commit if another commit happens after, before the timeout, or before you confirm again?
Let me show you the RFC quickly. Okay, so the commit confirm capability is the following, okay? A confirm is an operation that will be reverted if a confirming commit is not issued within the timeout period that is provided as part of the commit confirm command, okay? And it will roll back automatically. That's the goal of that commit confirm. And so, if I show you, for instance, real quickly, I don't know if this is going to help, but I'm going to show you a bit of code because I like code.
Yeah, let me know when you're done because I have a point.
I'm not done. Okay, so what we have here as part of the commit function is you can pass some variable if you want to, and by default confirm is false and config timeout and so on. Okay, but also there is one thing that you can provide in the commit when you commit confirm is whether to persist or not this config. Because if you do a commit confirm and you lose the session to the device will roll back. If you use a commit confirm and you persist, then it will be persisted with a given ID, and you can reconnect to the device and confirm the commit using that persisted ID. So that way you don't lose what you confirmed, okay? So now the idea is when you have a script and you need to configure multiple devices, well, what you want to do is, what I'm going to show here is pretty much the way I implemented this. You see here, where is it? Here I'm doing a for loop basically on all my devices. When I have multiple devices to configure, I'm going all over my device list, okay? I'm gathering its IP, the config for ISIS, the config for my interface. So, you know, this is this use case that I'm talking to, okay? And then here I create my netconf client. In this case, I'm using NC client, okay? And then I add my client to a list of clients because later point in time I'll need it. And then I push the config. And here, when I'm pushing the config, what I'm doing is I'm doing a lock, edit config, but then I validate, then a second edit config, validate, then I do a commit, confirm true, and I give it a timeout. This is 60 seconds, for instance. And then I'm done, okay? And so I do that for all the devices. But if one of my commits failed, so if while doing this, it failed for some reason on the device, so I catch an RPC exception, an RPC error, what I'm going to do is I'm going to try to discard the change on the device that currently failed, and then I'm going to tear down all the session for the list of netconf clients that I have ongoing. And basically, I'm just closing the session here. And as I said, as I don't persist in my commit, it will roll back as soon as the session is tore down. And so that way, I'm achieving an atomic transaction against multiple devices.
So just a quick question, Alexi, how do you extract all the configlet contents that are related to this action?
Oh, okay, so that's of interest for you? It's very not the topic, but I can explain. So, can I share the ISIS stream file? Huh? You don't think so? I don't think I can share that.
No.
Oh, okay.
I can share the script. I can share the scripts here. Okay, but okay, you know what? I can describe the idea. Okay.
You can describe the idea, it's a generic idea.
Because the script here I can share because this is pure netconf, but the config and so on. But the idea I can share and I can whiteboard.
But it's just a CDS way of extracting.
Yeah. So, but okay, maybe there is what I can share is this. Okay, there is one. I won't share the config itself because I think this is what is proprietary. I think I can share just the overall blueprint that explains how I'm stitching things together. That I think is okay, or what do you think?
Oh yes, depends what's in there. But
Yeah, no, there is no config, no password, nothing here. It's just.
Okay, so I think it's fine.
No, but the idea here is the following: is so you see. So here I said. Here I didn't set this. I formulated like this: configure ISIS on these PNFs. It means that the PNF is going to be an input. You agree? And so I'm going to have a list of PNF as input provided.
So for a given action, you will generate configuration for a list of VNFs. Yes.
So if I show you a little bit the CBA, I have a list of hostname here. That's basically the list of my PNF. Okay? Okay,
so here you get the list of hostnames. Okay?
Okay. Then in this specific use case, well, you know, the way it's built, it doesn't matter, but I'm going to have one component resource resolution where I'm going to basically assign the config. And here I'm going to assign the interface and the ISIS config, and I'm going to do it, and I'm going to run it for the number of devices that I have as input. So if I have 3 devices, I'm going to do it 3 times. If I have 10 devices, I'm going to do this specific resolution action 10 times. Okay? So the occurrence here allows me to specify how many times I want to do that resolution. Okay? And then, basically, all this is going to be stored, you know, in the attribute. You agree?
Yes.
So then I'm calling. So here I'm using. I'm fetching from ANAI the loopback IP for each of my devices. Okay, and I'm aggregating them again in the template, and that template is a list of hostname. Is a list of IPs.
Right.
So that's where I get from hostname to IPs. So on one end, I have a list numbered from 1 to X that contain the config for each device. On the other end, I have the list from 1 to X of the IPs that I need to use. I'm using a TACAX credential that I provide as input here. You see here I provide password username as input. It's TACAX basically.
And also at some point you infer the network ID of your ISIS from the router ID.
I don't want to talk about that. This is like our secret sauce.
It's
and then,
secret.
Okay, but, and then I use that script that I just shared to you, my commit script, so that's the one that we're looking at. Let me just bring it back up, because I think it has interest. Okay, then I'm using this script, and to this script, so I'm passing some properties here. The property I'm passing to my scripts is basically username, password, and the number of devices that I have. Basically, that's what that means. And then I'm passing what we call what we have dynamic properties here, and this is so the dynamic property, and this is basically the outcome of my resolution for the config and the outcome of my resolution for the IPs. Okay. Reason why one is using argument, the other one is using dynamic properties, is because dynamic property is going to be JSON encoded type of payload that I receive in my script, whereas argument, this is like a string. Okay, and so that's why here in my script, if I look at the main, I have 1, 2, 3, 4. Oh yeah, because also something else is the dynamic property, it gets added as the last argument of the script when you execute a script. If you provide dynamic property, it's going to be the last argument of that script. And so here I have first argument, username, password, occurrence, and then the dynamic properties. That is the last one. And from the dynamic property I can load, and in there I have my IPs, and I'm fetching the host IP, and I have my config, and in there I have IS/ISR interface. And so that's how, from the resolution, I get to the config. And so, and all I have here in the template, I won't show, but I have the IS/IS interface and host. And that interface and IS/IS I can reuse all across my backbone, because it's the same config for IS/IS all across the backbone.
Right.
And so that's how I have achieved this use case. And so now back to our current topic, that is this atomic transaction. Because here the reason why there is a if here, because a smart guy might want to configure just one device and not multiple, and if it's one device, then the output of my resolution is slightly different because of the JSON formatting. So that's just the catch. Anyhow, the real idea here was to explain the commit confirm capability and how easy it is to have atomic transaction when you can leverage this commit confirm capability.
So how do you use the question? So you at some point you confirm the...
Oh yeah, okay. So here, okay, sorry. So here, for my list of device, I go here, then I push the config, okay? Then if something went wrong, I tear down all the session, else I move on. And then here, okay, configuration successfully pushed to all the device, I will now confirm. So now for all the client that I have in my client network list, I will commit. Well, it's commented out because, you know,
okay.
Doing testing, but...
Okay, what happens if you committed to the first two devices and you fail to commit on the third one because it became unreachable?
Yep.
What are you going to do now?
Well, I'm going to tear down all the session, and it will roll back automatically.
It tears down, but he already committed to the first.
He didn't commit.
No, I did not commit.
Oh, but what if you did a confirm for the first two and then before you confirm the third one, the connection got lost?
Thank you, Munir, for bringing always these nifty edge cases. Okay.
I have the answer. Mediation, I will handle it.
No. What you're saying is, the assumption here is that if the commit confirm went through all the devices, commit will go through, okay? Now, what you're saying is, assume you have network connectivity issue in between and you screwed, man.
Yeah, but I mean, what I'm saying is, this is not so much different than the other ones which does not support commit confirm, because what if you confirmed on two of them and on the third one you failed to confirm, now you have to roll back to the first two because you...
No, but the reality is, if you were able to do commit confirm and to confirm on two, if you were able to do commit confirm, the probability that you can confirm all of them is very, very high. So I agree with you. There might be a case where you would fail.
In that case, but...
And in this case, look, it's even here. Failed to commit change, manual intervention required. That's how I'm answering it today.
Yeah.
But you see, I'm catching the exception. If you want, you can put more logic.
Yeah, but because you said that if you did not confirm, it automatically will roll back. So if you did not confirm in 60 seconds, the third,
Everything will roll back, yeah.
will not have it, only the two will have it. No, because you confirmed on the first two.
Yeah.
No, but yes, so
Third
that's
one
what I'm saying.
not have it.
That's what I'm saying. If what you said is happening, it falls here,
Yeah. Okay.
here,
All right.
and you need to manually fix the issue.
Yeah.
But that edge case that you're discussing, Munir, is a very rare one, because if up till now you were able to communicate with the device for all the subsequent transactions that you've done, and you've done maybe 15 before.
Yeah.
The probability that the last one that you need to do is going to fail due to network outage, you might have this.
Well,
And I'm not ruling it out, but
If you have a network outage, even if you implement an undo action, you won't be able to do it.
yeah, exactly. Actually, yeah. Thank you, Matt. Thank you for saving my ass.
No,
I waited 5 minutes.
no, he hasn't saved it yet. Hold on.
Screw you, Munir.
So the third one is not reachable. Let's say it was the management network, but automatically he rolled back. But you did not roll back the other two that you already committed.
Well, how do you
Have connection too late at this point.
Yeah, given you have connection to 1 and 2.
It's
You
good.
have not unrolled or undone the 1 and 2 that you have connection. But the third one, you lost the management, but the device is up. He already rolled back after 60 seconds.
Yeah, so that's why manual intervention is required.
Yeah, no, I agree.
But to that use case, very easily here, line 63, you can add the logic you said.
Yeah,
It's like maybe it's 10 more line of code,
yeah.
and that will not be too hard to add. Like if I commit and it failed in the third one, then I need to do the rollback of the two previous. But then, how do you do the rollback?
Can we use the word?
Because but the tricky part is, here it's good because, it's network RFC, commit confirm. But if you're past the point and you committed to the device already, there is no RFC, nothing to tell you how to do a rollback.
Right. No.
And so that's where it's very tricky. Either you're using a delete template, but at this point in time, I don't know the delete template.
I think the delete template is.
No, exactly. So Mike is
Yeah.
saying maybe you could revert to a commit ID, but maybe vendor A will support
Yeah, but you.
flavor of it. And
That's when you get to revert the last commit.
so, but this is very vendor specific at this point.
And with the law, like the way we achieved it for, we have done it, right? Like,
Yeah, but so that's where,
Talk and then.
so that's, the idea is, and always nice to have this corner case brought by Munir, but, so the idea is for,
Question, these are happening sequentially?
yes,
Are we also looking at ways to do this in parallel for all
later,
devices? Not within the script, just generic.
in this case, if you want atomic,
Yeah.
actually, this push config here, this execution of this function could be parallel.
It should be parallel, right?
It could.
we have done parallel using futures. So it basically goes and that's all.
It could.
They all wait at the same step.
It could be parallel.
Could it be also streamed so that that we don't?
Whatever is the tech, it can be parallel. Whatever is you're going to use to parallelize it, it can be parallel, yes.
So there is no limitation to make it parallel. All you have to do is stop and wait for all.
But the point is, at some point, you're gonna want to gather all the results. But anyhow, this is just, and that script here, please keep in mind, this is just a POC I've done here to prove some points.
It's one way of doing it.
It's one way of doing it,
I personally like the delete because you're gonna have to delete at some point.
Yeah, if you
Right,
implement
you need to have the delete payload if you want to remove the VNet. So if you, at least that's what I did for one of our projects, is I create payload and delete payload at the same time during the config assign part. So now I have those payload ready, I need to delete.
Yeah.
It could be used for the rollback, so that you don't have to lock, you don't have to maybe do the commit, and it will always work unless you lose connectivity directly to it.
I think it depends on your use case, because in some case, if it's a config element that may be used for other services on the device, you may not want to delete it.
Yeah.
Go back.
Yeah. So
Yeah, but now, obviously it depends on the use case, but you need a higher,
That's my point, that's why it's good to have the flexibility, but
Like-
we'll have use case where you don't want to fire delete.
like the IFS configuration is specific to that VNF, right?
yeah. So
It's not gonna be reused by something else.
Oh, this one, yeah, it's specific.
So because you attach it to a VRF and.
Yeah.
there could be another edge case. Let's say you're adding a VRF, and that VRF was already there for that interface, but your add was re-adding it, but it was not hurting. But then if you do your undo using some kind of rollback, that's better. But if you do a delete, you actually remove something that could have been used by somebody else.
That's true, this is a different.
Yeah, that's a valid point,
I
yeah.
configure but I need to configure the VRF if it doesn't exist.
But look, it's a
So
bunch of
it can still fail
corner cases, right?
But
I mean,
by default,
before-
if you try to create the VRF and it already exists, it's going to fail.
Yeah.
It's going to fail by default.
Netconf?
That you don't-
Oh, no,
Why
Netconf,
would it fail though?
Netconf, if you do merge or replace, it won't
Yeah,
fail.
it won't fail.
Oh, yeah, replace it won't.
Yeah, it won't fail, even merge.
And then,
But then you took the decision so that it doesn't fail.
Yeah.
So.
Yeah, so-
There's different ways.
Okay, so what we're talking about here is the netconf operation. So people not familiar with netconf, whenever you do a netconf operation, you can define,
Remove or delete.
yeah, let me try to get there.
I discovered that recently.
yeah.
Did I share that with you?
The difference between.
No,
That's how-
found it in that document.
That's how we implemented the whole tenant overlay,
Search for delete.
the whole overlay, IS Fabric overlay. That's what we've used.
That's delete.
No, it's edit config that I care about. Edit config operation, there you go. And this is merge, replace, create, delete, remove. Yeah. So whenever you do an edit config, you can specify the operation on the specific, container. Or if you're familiar with Yang, it's a container. If you're not familiar with Yang, it's like a XML block, and you can specify the operation for that block. And either it can be create or delete. And some things that we've done here is we have a netconf payload, and we do parameterize is blocking this netconf payload with the operation, and so that way, when you need to generate the payload to create, well, we use create as operation, and to delete, we use delete. So one payload, and we solve both of them. So that's an idea, but again, it's with netconf, right? If you don't have netconf, but you have CLI or RESTconf, you might need to look at different solutions. So the point was I wanted to share this a little bit for the commit confirm, but I think we don't have any very good platform capability for, when we don't have that commit confirm. So when we have the commit confirm, it's very easily, designer can provide that in their own script, in their own fashion. But else, I think we need some platform capability to say that, hey, a transaction to a device is a functional interface that should both have a commit and a rollback. And so that way, pretty much, Munir, the way we implemented this with Kemen, right? But I think we should have that such functionality provided by CDS as platform capability. What do people think about this? Do people have experience they could share around this and so on? I shared mine, maybe people have some others.
I think it's good that it's a platform, because this is a feature that everyone that works with PNF or configure PNF will need to do. So either they're going to have to do it all the time in their script because it's not supported on the platform, or the platform can do it in a more streamlined way and they could just use it. Because if you most of the time we configure multiple PNF, something happens in one, it needs to go back. This is common in all our use cases, right? You don't want to leave stuff or like sub-interface on the Tor if not all of the process was. I think it makes sense that there's something on the platform to support that.
Yeah, and the implementation will be a little bit various depending on what you're dealing with.
It depends on like Max said, there are different ways to tackle this based on the use case.
Yeah.
Maybe that's where it gets tricky, but.
Few variations of it will be better.
Je lui ai dit, mais plutôt belle plateforme comme ça. Mais je dis,
Can you give me your
ça n'a rien à voir avec la chose.
sharing? No,
Chier. Chier, mais ils veulent pas faire ça.
all because Bonaire forgot.
Même, ils veulent pas. Parce que je lui ai dit, on en discute aussi assis.
Neither will guess nor will one is working.
Oui, on en discute aussi.
C'est quand même, de toute façon, on va dire, pour le projet,
Belle
c'est aucune
plateforme.
importance.
Belle plateforme.
La plateforme, c'est universel.
S.O. belle.
That one works for me.
Yeah, well,
Après,
I figure it's
Ça n'a rien à voir avec la chose.
Okay, what do you want to do? Just this email. Can you forward the latest one? At that? To you.
have a file, 1 hour free.
What's the email?
Thing is, I'm not using speech. Yeah. I don't want to change my numbers.
You don't have to change the number in the short.
No, but my number is from Ottawa, Ontario.
My number is from St. John, New Brunswick.
No, if you change the carrier,
And his
you
email.
have to.
Oh, yeah?
Yeah.
Oh, you look.
Yeah. Other.
So let's see, with the imperative workflow implementation, you know how we have cases of success?
I'm not even I'm from Ottawa.
You can just have a rollback action if there's a failure in an atomic way.
I think you don't want to lose the context.
Context is not going to be lost, right? Why would it be lost? Because if it's a failure,
If you have a bunch of, if you have the delete template.
yeah,
Then yes,
you
absolutely.
trigger the rollback action. If it's a failure, and you generate the context, and you push it. So Brenda's implementation for imperative workflow it gives you the
Regardless the work of DG or corrective work.
Oh, DG, yeah.
Both will work,
They will work.
Collecting that money?
But so what we're gonna say for the users is, you need to provide the delete template.
Exactly. The only thing I don't know, if the delete template or, rollback, right? Regardless, there's still actions or playbooks, right? So I don't know if the main thing here is that we need to extend the support for the queuing mechanism to make sure that we lock when we do all the actions within that itself. I think that's the main thing. Everything else is already provided by the framework.
I log out. Is anything else?
There?
Write the box for that actually.
Very good.
I actually was going on mute, I was like,
So, what I will do is I just add one requirement to just do an additional lock itself if we have such a use case, regardless of RESTconf or NetConf, gRPC,
Yes, CLI,
whatever it may be, that queuing mechanism will support. Sorry. Can I stop this recording?
Do we